Hello, welcome to our fourth video lecture, which is on module 4, that is arrays and strings. In the previous video lecture, we have discussed about how to declare a two-dimensional array, how to initialize it by taking user input, as well as few programs like how to find the sum of all the elements, how to find the sum of first diagonal elements, like this. And I also asked two questions that you are supposed to write a program to find the sum of second diagonal elements, find the sum of boundary elements. I hope you have seen that video lecture and you tried that two programs, which is your worksheet, right? In today's session, we will write few more programs based on two-dimensional array. What are the programs that we are going to see today? The first program that we will see today is to calculate transpose of a square matrix in itself. Second program we will see today is to perform addition of two matrices to find the result. And the third program that we will see today, which is little complicated, is to perform multiplication of two matrices. So in this session specifically, we are going to solve three problems: transpose, addition and multiplication. Let's start with the first problem, that is transpose of a given matrix. For that, let's consider a 3 by 3 square matrix like this. I am assuming the user has entered or initialized the elements of this matrix as follows. The first element entered by the user is having value 1, second element 2, third element 3, likewise 4, 5, 6, 7, 8, 9. I have also mentioned the row index number and column index number for every element, because these are very important while we are processing the elements of the given matrix. This is the original, and our aim is to find out its a transpose. Manually, can you calculate transpose of this matrix? Yes. Transpose is a simple procedure in which I have to convert the row of the original matrix into the column in the transpose. For example, the transpose of this matrix will look something like this. The first row of a given matrix, that is 1, 2, 3, will become first column in the transpose 1, 2, 3. The second row of the original matrix, that is 4, 5, 6, will become second column in the transpose, that is 4, 5, 6. And third row of the original matrix, that is 7, 8, 9, will become third column in the transpose of a matrix. So this is what is our input. User will enter this matrix as an input to my program, and this is what I wanted to show as the output, that is transpose of a given matrix. Now, how to achieve this? Let's go through the procedure. When we wanted to calculate a transpose, we have to make one important observation. What is that observation? Let's observe. This is original, this is transpose. If you find these three elements of the original, that is 1, 5 and 9, in the transpose, they will appear at the same position, 1, 5 and 9. These are the elements present on the first diagonal of a given matrix. So when we are calculating transpose of a given matrix, the elements present in the first diagonal are required to be kept in their original place. We need not have to manipulate them. What about other elements? Let's check. So what we wanted to do is keep these three elements at their original place. We need not have to do anything with them. With the other elements, we need to do the processing like this. The first thing that I need to do is I need to swap the element whose value is 2 with the element whose value is 4. And to do this, I have to write a code to perform this operation. This is M01. I should swap it with M10. So 4 will come here, 2 will go here. Next step that I need to perform is I need to swap these two elements. To perform swapping of these two elements, I need to write a code to perform this operation. That is M02 is required to be swapped with M20. Next thing that I need to do is I need to swap these two elements 6 and 8. To perform this operation I need to write a code which will perform swapping of M12 with M21. So in order to calculate the transpose of this matrix in itself, we need to swap 3 pairs. In general, what we need to swap is Mij with Mji. You can observe, if this is I and if this is J, then this is Mij, we need to swap with Mji. Mij needs to be swapped with Mji. Mij need to be swapped with Mji. So this command or command required to perform swapping of Mij with Mji is required to be executed repeatedly. But if I do it without any condition, it will create a problem. So we require one condition which will take care of a proper transpose calculation. Let's go to Turbo C to find out that how we can achieve this. Okay, so let's open a Turbo C environment. We'll try and write this program quickly. We will declare a matrix two-dimensional array M with arbitrary large size, let's say 10 by 10. If you recall from the last video lecture, we require I and J as the index variables inside this. We require R and C as the number of rows and number of columns. And since we need to swap the elements, we require a temporary variable T. So these are the variables required. The first dialog that I will have with the user is, I will ask the user enter size of square matrix. Remember, this procedure, whatever we are implementing, is applicable only for square matrix. Which matrix is a square matrix? A matrix whose number of rows will be equal to number of columns. That matrix will be called as square matrix. I will ask the user to enter the size of square matrix. We will read it by writing scanf %d, address of R, address of C. What is necessary is R should be equal to C. If that is true, then only this is a square matrix and we should implement our procedure. Let's have the condition which will actually check is it a square matrix. So I will write a simple condition, is R equal to C. If yes, we can calculate it's a transpose. Otherwise, we will give a message to the user saying printf transpose, or instead of saying transpose not possible, because transpose is possible for every matrix. For our program, we require a square matrix, so we will give a message not a square matrix. So we will give this particular message to the user, not a square matrix, and my program is not able to calculate its a transpose, right? Now what we need to do is, we have written if else. If the condition is true, we will calculate the transpose and display it. If it is not true, we will simply say it's not a square matrix. But if it is a square matrix, we have to accept the elements of that matrix from the user. So I will write printf, I will ask the user enter elements of the matrix. And you know how to read the elements of matrix. We require two for loops. For I is equal to 0, I less than R, I plus plus. Inside this, to change the columns, we require another for loop. For j is equal to 0, then j less than c, j plus plus. Inside this, we need to write a scanf command. Let's say scanf %d, and we should write address of Mij. So the element will get initialized by changing values of row index number and column index number. This completes our input operation. So now the matrix is ready with me, and now I am supposed to calculate its a transpose. To calculate a transpose, just now we have seen we need to perform swapping of Mij with Mji. We need to swap Mij with Mji. How to swap Mij with Mji? The procedure is simple. what we are going to do is we need to write t is equal to mij. That will copy value of mij into t. Then we will write mij is equal to mji. So mji value will come inside mij, and then lastly what we'll write, mji will be equal to t. So this is a simple procedure to swap any two values. So I am swapping mij with mji, but this will swap only one pair. We need to swap many pairs, and for that we need to keep this procedure inside a pair of for loops. So again I will write for loop for I is equal to 0, I less than r, I plus plus. Inside this we need to write for j is equal to 0, j less than c, j plus plus, and inside this for loop we will keep this procedure, that is to swap the pairs. And after this we will write a message printf, and we will say transpose is equal to \n, and we will write a procedure to display the transpose of a given matrix. So I will write printf, we will write for loops because we are displaying matrix for I is equal to 0 again, I less than r. I will just scroll down so that this will be clearly visible. I plus plus. Inside this I will write another for loop for j is equal to 0, j less than c, j plus plus. Inside this we need to write printf. We will write %d \t. We will display value of mij, and then after this for loop, since the number of columns in the given row are over, we need to change the line by writing printf \n, as we have seen it in the last session, if you remember. So this is a very standard procedure to display the two-dimensional array in a matrix form, right? So we will display the transpose that we have calculated in a proper matrix form by using this, and this everything is present inside if. So this all, that means accepting the elements of the matrix, swapping them by using for loops, and displaying the result will be performed only if the condition is true. Which condition? R is equal to C. Otherwise we will simply say not a square matrix. Let us compile our program. You can see there is no error. We will run it. Now it will ask me the size of square matrix. So let's say size of square matrix is 3 by 3. It will ask me enter the elements of a matrix. The beauty of this input procedure is I can enter matrix in a matrix format also, like this. Let's say first row is 1 2 3, next row is 4 5 6, and next row is 7 8 9. So I have inserted, or I have inputted the square matrix of size 3 by 3. When I press enter, it will say transpose is equal to, and to our surprise it is displaying the original matrix as it is. But we have written a procedure to swap the values like this, mij and mgi. We have written a procedure to swap the values, then why it is again displaying the original result? Yes, the problem is when we swap mij with mgi, they will get swapped, but again when it goes ahead, mji will again get swapped with mij. That means they will come to the original position. So this is the problem. How to avoid this problem? We need to have one condition. What is the condition that we need to have? 2 should be swapped with 4, but afterwards this 2, whatever is coming over here, should not get swapped with 4 again. Similarly 3 should get swapped with 7, but they should not be reswapped. Similarly 6 should get swapped with 8, but they should not be reswapped. That means we need to stop the swapping at a particular condition. What is that condition? If you observe these 3 elements, that is 2, 3 and 6, they are present above this diagonal, first diagonal, and they satisfy a particular condition. What is the condition these 3 elements satisfy, which is not satisfied by these 3? which are present below the diagonal. If I observe, this is I, this is J, this is I, this is J, this is I, this is J. So for these three elements, I is less than J. But for these three elements, it is not true. So I should swap the element pair only if I is less than J. And this condition I need to insert in my program. So now let's go back into Turbo C in our program. This is swapping the two elements without checking any condition. Now here we will add a condition. We will say swap only if I is less than J. Only if this condition is satisfied by an element, then it will be swapped with its corresponding pair. So by making this simple change, by adding this condition, we will again compile our program. We will run it. Again I will specify the size of the matrix is 3 by 3. Again we will enter the same matrix, let's say 1, 2, 3, first row, 4, 5, 6 as the second row, and 7, 8, 9 as the third row. This time when I press enter, what you will find, the transpose is calculated properly. The first row of the original becomes first column in the transpose, second row becomes second column, third row becomes third column in the transpose. So this is how we can calculate transpose of a given matrix. So you again revisit this program right from the beginning till the end. Try to write it on your computer, on your machine, and try to execute it. Okay, this will calculate the transpose of a given matrix. If you understood this program, then I got one more question for your worksheet, and that question is, I want you to write a program to check the given matrix is symmetric or not. What is the problem? Check the given matrix is symmetric matrix or not. You all will try that program also as a worksheet problem. So in our worksheet now there are three programs. First program is to find sum of second diagonal elements. Second problem is to find sum of the boundary elements of the given matrix. Third problem is to check the given matrix is symmetric or not. Let's go to the next problem that we wanted to solve today. Next problem is about the addition of two matrices. So I wanted to write a program to perform addition of two matrices and store the result into third one. So let's consider there are three matrices X, Y and Z. So the X matrix is initialized by user. Let's assume these values are specified by user. Y matrix is also initialized by user. Let's assume these are the values entered by the user. What I wanted to do is I wanted to add these two matrices and store the result into the third matrix whose name is Z. In matrix addition, what we need to do is we need to keep on adding corresponding elements from both the input matrices. Like I need to add 1 with 10 to create a result 11. Similarly, I need to add 2 with 20 to create a result 22. Similarly, I need to add 3 with 30 to create result 33. So I need to execute the expressions like this. This is x00. I need to add it with y00 and I need to store the result in z00. Similarly, this is x01. I need to add it into y01 to store the result into z01. Similarly, I need to add x02 with y02 to store the result into z02. Likewise, I have to keep on adding all the elements of the two given matrices to create the result. So this is our second program. So now let's go back into Turbo C and we will try and write this program. Now, what do we require to complete this program? Can you guess the list of variables that we need? Yes, we require integer variable, let's say x of arbitrary large size 10 by 10. We require another integer variable array, that is y with arbitrary large size, let's say 10 by 10. We require third array also, that is z with arbitrary large size 10 by 10. So we require three matrices x, y and z. Now let's take other integer variables required. As you know, we require I and j as the index inside the matrix. Then let's take R1 and C1 to define size of first matrix, that is x. Then let's take R2 and C2 to decide size of second matrix, that is y. And let's take R3 and C3 to decide size of third matrix, that is z. Because three matrices are there, they can have same size or they can have different size depending upon user input. User has to decide that what will be the size of x, what will be the size of y. Depending upon their sizes, the size of z will be decided, right? So R1 C1 will define size of x, R2 C2 will define size of y, R3 C3 will define size of z. So these variables we need to take. Let us clear the screen, and then one by one we will start the input operation. So we should read the first matrix from the user. For that I will ask the user enter size of first matrix. I will ask the user to enter the size of first matrix. To read it I will write scanf, let's say %d, %d. R1 C1 will define the size of first matrix, so I will write address of R1 comma address of C1. So first matrix size is in R1 C1. Now either I can read the elements of first matrix or I can read the size of second matrix. What is better? I think the size of second matrix should be accepted first, because we cannot add any two matrices. The two matrices can be added only if their size is same. So before reading elements of the two matrices, what we'll do is we'll read their size, we will check whether they can be added or not. If yes, then only we will accept their elements and we will perform addition. So now instead of asking elements of first matrix, I will ask the user to enter size of second matrix. So let's read the size of second matrix from the user. I will read it by using again scanf, %d, %d, address of R2 and address of C2. So second matrix size will be stored in R2 and C2. Now to add the two matrices, we require to satisfy one condition. What is the condition that we need to satisfy? R1, number of rows in first matrix, should be equal to R2, that is number of rows in second matrix. But this is not enough. And number of columns in first matrix should also equal to number of columns in second matrix. So if this condition is satisfied, then yes, we can perform addition of two matrices. But if any of this condition is false, then we cannot perform addition. So I will write printf and I will write operation not possible. I will give this message to the user. Then we will write get ch, and that is end of our program. So now you might have understood that we are having two options. If the matrix size entered by the user is confirming, that means they are having same size, then we can accept their elements and perform addition. But if their size is not same, we will simply display message operation not possible. So let us accept the elements of matrix 1. So for that again we need to write printf, we'll ask the user enter elements of matrix 1. To read the elements of matrix 1 we require two for loops. Let's say for I is equal to 0, I less than R1, then I plus plus. Inside this we need to write for, let's say j equal to 0, j less than C1, j plus plus. Inside this we need to write scanf, %d, and we write address of xij. So this procedure we initialize the elements of matrix X. Exactly same procedure we require to initialize the elements of matrix Y. So let us copy this procedure and I will paste it one more time. So exactly same procedure I have copied and pasted. But this time what I will say enter the elements of matrix 2. Then the size of matrix 2 is decided by R2 and C2. And then here instead of X I will write Y. This will read or accept the elements of second matrix. Now we need to perform the addition. To perform the addition, we need to write two for loops. Let's say for I is equal to 0, I less than R3, I plus plus. Inside this, we need to write for j is equal to 0, j less than C3, j plus plus. Inside this, we need to calculate the elements of matrix Z by writing Zij will be equal to Xij plus Yij. So this expression is required to be executed again and again. Why we have taken R3 and C3? Because where we are storing the result? We are storing the result into the matrix Z, and its size is defined by R3 and C3. But the problem is R3 and C3 are just declared and they are not initialized, because user cannot decide what will be the size of Z. User can decide the size of X and Y. We have to decide the size of Z. So what will be the size of Z? It is very simple. The number of rows in the result, that is R3, will be equal to either R1 or R2. It has to be of same size as the input matrix. Similarly, number of columns in the result will be either equal to C1 or it can be said equal to C2. So the first thing that we will do before calculating the addition, we will define the size of the result, and then we will calculate the elements of the result. So our result is ready. It's now the time to display the result. So I will write printf and I will write result is equal to \n, and again we need to write two for loops for displaying it in a proper matrix format. For I is equal to 0, I less than R3, because we are going to display the third matrix, that is Z matrix, whose size is R3C3. I plus plus. Inside this another for loop. Let's say for j is equal to 0, then j less than C3, j plus plus. Inside this we need to write a printf command. We need to write printf %t \t, and whose value we will display? We will display the value of Zij. And then to change the row in the output, we need to write printf double quote \n double quote. This will change the row. This will display the result to the user. Okay, and then this is the end of if. So if the condition is true, if this condition is true, if the size of the two matrices entered by the user is same, then we will read the elements of matrix 1, then we will read the elements of matrix 2, then we will define the size of the result matrix, and we will calculate the sum of the matrix. And after calculating the sum of the two matrices, we will display the result by using two for loops. So this all will be performed only if the addition is possible. Otherwise, we will simply display a message operation not possible. Let us compile this program. There are three errors. The errors are like this. I have typed a comma instead of semicolon over here, so replace it. Again I will compile. Now the errors are gone. We will run our program. It will ask me to enter the size of first matrix. So let's say first matrix size is 3 by 3. It is asking me to enter the size of second matrix. What if I say the size of second matrix is 2 by 3? Directly it will say operation not possible, because the matrix size is not equal. Again we will run this. Now let's say size of first matrix is 3 by 3. Second matrix is also 3 by 3. Then it will ask me to enter the elements of matrix 1. So let's say they are 1, 2, 3. Then 4, 5, 6. Then 7, 8, 9. Then it will ask me to enter the elements of matrix 2. Let's say they are 10, 20, 30. 11, 22, 33, 1, 2 and 3. I am entering any arbitrary elements. So I have entered both the matrices. When I press enter, this is what will be displayed as the result. And as you can see, what is performed: 1 plus 10 is 11, 2 plus 20 is 22, 3 plus 30 is 33, 4 plus 11 is 15. Like this, each element pair from the two matrices is added and stored into the result. This is how we can perform the addition of two matrices. Now, by using this program, can you write a program to perform subtraction of two matrices? Obviously you can. It is very simple. What we need to do is simply replace this plus by minus. So if I replace the addition by subtraction, it will calculate the subtraction of two matrices. So it is very simple. You try these two programs, performing addition as well as performing subtraction. But can we perform multiplication of the two matrices by just replacing this by star? The answer is no, because multiplication of the two matrices is not performed by taking element by element pair, right? The multiplication process is a little complicated than addition and subtraction. So let's check what is different in multiplication, what we need to change when we wanted to perform multiplication of two matrices. Let's go to our presentation again. Okay, I have got a very small video for you which will explain how the two matrices can be multiplied. So let's check this small video. You can see there are two by 2 matrices. First we need to multiply A with E, and into that we have to perform our addition of B into G. Then we need to perform multiplication of A with F, and then we have to add B into H in the result. Then we need to perform multiplication of C and E, and into that we need to add the multiplication of D and G. Then finally we need to perform multiplication of C and F, and into that we need to add D into H. So it is the row into column, row into column. Finally this will be the result of the multiplication of two matrices. So in order to perform multiplication of two matrices, what we need to do is we need to select the row of first matrix and multiply it with the elements present in first column of the second matrix. Then again first row, multiply it with second column. Then second row, multiply it with first column. Then second row, multiply it with second column. So it is row to column multiplication. So we need to select row of first matrix. At the same time we need to select column of second matrix, as well as we need to select element from these both. So we require 3 index variables, I, J and K. Let's say I is used to select the row of first matrix, J is used to select the column of second matrix, and K is used to select the element from these two selected entities. Let's go back into Turbo C and write a program to perform multiplication. Now, if you are aware that the two matrices can be multiplied only if they satisfy a particular condition. What is the condition we need to satisfy to check the matrix can be multiplied or not? Okay, can we multiply a 2 by 3 matrix with 3 by 4 matrix? The answer is yes, because number of columns in first should be equal to number of rows in second. So in order to perform or check the multiplication is possible or not, what we need to check is we need to check the number of columns in first matrix, are they equal to number of rows in second matrix. So C1 is the number of columns in first matrix, is it equal to R2, that is number of rows in second matrix. If this is possible or if it is there, then only multiplication is possible. So this is the condition. Then the procedure to perform input operation of first matrix and second matrix will remain same. There is absolutely no problem. What would be the size of the result in case of multiplication? In case of multiplication, the number of rows in the result, that is R3, will be equal to number of rows in the first matrix, that is R1, that is correct. But how many columns will be there in the result? number of columns in the result will be equal to number of columns in the second matrix. Okay, so for example, if I multiply a 2 by 3 matrix with, let's say, 3 by 12 matrix, then what will be the size of result? Size of result will be equal to 2 by 12. That is number of rows in first matrix, that is R1, and number of columns in second matrix, that is C2. So this is how we will decide the size of the result. Now these two for loops will remain same for I is equal to 0, for j is equal to 0. Inside this for loop, what we need to do is we need to initialize the element of the resultant matrix to 0 first, because it is sum of partial products. So since it is sum of partial products, we need to accumulate the sum. The first value of the result should be 0, and then inside this we need to write one more for loop for k is equal to 0, then k less than, either it can be C2 or it can be either it can be C1 or it can be R2. So let's take C1, which is common in both the matrix, and then we will write k plus plus. Inside this for loop, we need to write the multiplication expression, which is going to be Zij will be plus equal to means shorthand operator. We need to write Xik, because I am selecting the column of the first matrix by using k, and then I have to select the row of the second matrix. I have to write multiply Yj. So Xik will be multiplied with Yj, and the result will be stored into Zij. Let's store this, and then finally we will display the result. So everything in the program will remain same, except that we require one additional variable that we have taken, that is k. Let us compile our program and we will run it. It will ask me enter the size of first matrix, let's say 2 by 2, enter the size of second matrix, let's say 2 by 3. Can we multiply these two matrices? The answer is yes, because C1 is equal to R2. And then what will be the size of result? It will be 2 by 3. Let's check. It will ask me to enter the elements of matrix 1. So it's a 2 by 2 matrix. So let's say 1, 2, 2, 3. Let's say these are the elements of first matrix. Enter the elements of matrix 2, which is going to be a 2 by 3 matrix. So 2 by 3 matrix, that means 2 rows and 3 columns. So let's say first row is 3, 3, 3. Second row is 4, 4, 4. This is the 2 by 3 matrix. Now when I press enter, it will display the result of multiplication. How this result is coming? It will be like this. The 1 will be multiplied with 3, the result is 3, plus 2 will be multiplied with 4, that is 8. So 3 plus 8, it becomes 11. Here also 3 plus 8, 11. Here also 3 plus 8, 11. Here 2 into 3, that is 6, plus 3 into 4, that is 12. So 6 plus 12, 18. Here also 6 plus 12, 18. 6 plus 12, 18. The result of the multiplication calculated is correct, and you can observe the size of multiplication is also 2 by 3. This completes our third problem, that is how to perform the multiplication of two matrices. I hope you have understood the three programs that we discussed in this session. Again, I repeat, go through this video lecture completely, write your doubts, whatever questions you are having when you are going through these particular programs, and ask that doubts in our next Zoom meeting. I want every student should see these video lectures, make use of it, and then whatever doubts they are coming in your mind, you should ask it freely in the Zoom meeting. So See you soon in our next Zoom meeting. Till that time, goodbye.